Hey guys, today we're taking a look at a pretty sweet little technique used for finding the degree of a polynomial. That method is known as the method of finite differences, and it's based off this polynomial difference theorem. It says y equals f of x has degree n if and only if the nth difference of the y values are equal. So this method requires us to subtract the y values and figure out if they're equal. So have your calculator handy and let's jump into a few examples. Now, one thing you should know, when we are finding the difference in the y values, it's just easier to start on the right, and you always subtract the value to its left. So right minus left every time. Here we go. Example 1 says y equals 8x minus 4. It should have the differences in the first level, or in other words, the first set of differences between y values should all be the same. Let's check it out and see if it does. If I take 60 minus 52, I get 8. 52 minus 44 is 8. 44 minus 36 is 8. So as you can see, the differences when I subtract them are all going to be equal to each other. In other words, the first difference in y values are equal. Therefore, this means that this polynomial has a degree to the first power. All right, let's take a look at another example here. Example 2 says here is our function y equals 2x squared plus 4x. They give us the table of x values and want us to find the table of y values. So either plug it into Desmos and go to the table, or your graphing calculator, or you can copy my values down. I have 0 when x is -2, -2, then 0, 6, and 16. All right, let's start by finding the differences in the y values. 16 minus 6 is equal to 10. 6 minus 0 is equal to 6. 0 minus -2, make sure I got that right here, is 2. And then -2 minus 0 is -2. All right, so we can see that our first differences are not the same. Let's find the second differences. 10 minus 6 is 4. 6 minus 2 is 4. And 2 minus a -2 is also 4. So we see actually that the second differences are all constant values, again implying that this is going to have a degree of 2. And we know that this is true because these y values all come from a polynomial that had a degree 2. So this second degree polynomial is because it took 2 levels of subtracting to get a common difference. Now it says make a conjecture about the y value differences of ax to the third plus bx to the second plus cx plus d. Well, we see that this polynomial has degree 3, so our conjecture will be that it will be the third differences in y values that will be the same. All right. We're going to just finish our sentence here. There we go. Our third difference in y values will all be constant. All right, let's take a look at example 3. We're given this recursive formula. It says our first term is 4, our a sub n is 2 times the previous term minus 1. We want to find the first 6 terms. So we're going to make ourselves a table here. Our table of values goes like this. N is 1, 2, 3, 4, and 5. Oh, 6, we need our first 6 values. Our first term here is 4. Well, our second term can be found by doubling 4 and subtracting 1, so that should give me 7. Now I'm just going to use my notes here to fill in the remaining amounts. 13, 25, 49, and 97. All right. Now in part B it says to use the method of finite differences to determine if there is an explicit polynomial formula for the sequence. In other words, if it's a polynomial of a degree that can model these data values. So we're going to again just write out our y values here. We have 4, 7, 13, 25, 49, and 97. And we're going to work from right to left. So 97 minus 49 gives me 48. 49 minus 25 is going to give me 24. 25 minus 13 is 12, 13 minus 7 is 6, and 7 minus 4 is 3. So this is my first set of differences. I can see that they are not going to be equal to each other. So let's try our second differences. 48 minus 24 is 24. 24 minus 12 is going to give me 12. 12 minus 6 is going to give me 6. 6 minus 3 is going to give me 3. So again, our second differences don't give it to us either. Let's try our third, and the pattern continues here. This will be 12 this will be 6, this will be 3. So you can see that there's going to be no set of differences here in our y values that will be constant, that will be the same. So we say that there is no polynomial that models this data. So no polynomial for this data. All right, example 4 says determine if y seems to be a polynomial function of x, and if so, determine its degree. So we're going to use this method of finite differences. Again, just doing a lot of subtraction here. So we're starting off moving right to left. We have 521 minus 351, and I'm going to copy my notes on these guys here. 351 minus 223 gives me 128. 223 minus 131 gives me 92. 131 minus 69 gives me 62. And then 69 minus 31 gives me 38. 31 minus 11 is 20. That's 38 there. And then 11 minus 3 is 8. So here is my first set of differences. They are not constant values. Let's try our second differences. So again, I'm going to subtract these values. 170 minus 128 gives me 42. 128 minus 92 is 36. 92 minus 62 is 30. And 62 minus 38 is 24. What you might be noticing is that these second differences are not the same, but our third differences will be. 42 minus 36 is going to produce 6. 36 minus 30 is going to produce 6. 30 minus 24 is going to produce 6. So if you see that, you don't need to finish those lines out in your subtraction. You can go ahead and jump to that line that will produce a constant value. So I say, yes, there is a polynomial that will model this data, and it will have a degree equal to 3. All right, example number 5, we're going to follow the same procedure, do the method of finite differences. I'm going to leave the subtraction up to you. Start by taking 272 and minus 90. I'll give you the first value there. That is going to give you 182. I'll just give you the first row. 90 minus 20 is going to give you 70. 20 minus 2 is going to give you 18. 2 minus 0 is going to give you, is that 2? 0 minus 2 is going to give you negative 2. 2 minus 20 is going to give you negative 18. 20 minus 90 is going to give you negative 70. All right, your first differences did not make it. Go ahead, finish up with your second. It might take you to 3 or even possibly 4 in this one. You let me know what degree it is tomorrow in class for an extra piece